Good afternoon, guys. We are now going to discuss about the derivative of a composite function and the chain rule. So the chain rule is quite a challenging lesson, and so I would like to encourage your full attention, your full focus in viewing this video discussion. The chain rule, according to Lighthold in his book, The Calculus with Analytic Geometry, the derivative of the composite function f of g is equal to f prime of g of x times g prime of x. So to understand this formula better, let's have an illustration. Now you are familiar with the composite function, okay? So this composite function is equal to f of g of x, okay? So suppose you are given f of x equals sine x and g of x equals x cubed plus 1. So the x here shall be replaced by the quantity here, right? So that you have sine of x cubed plus 1. And so what is the derivative of this composite function? So first is we're going to apply this formula now. So the derivative first of your sine. So the derivative of sine is cosine, but do not forget to copy this. So you don't get the derivative of x cubed plus 1 directly. You have to copy that first. Okay, then times the derivative of that, which is 3x squared. The derivative of x cubed plus 1 is 3x squared. So you just imagine the chain, okay? You cannot move forward. Of course, you move forward while looking something at the past, okay? So in real life, what you are today is because of some parts of your past, or what you are today is a reflection of some parts of your past, okay? Not maybe all parts of your past. Anyway, so let's arrange this because this doesn't look good. So you have to transfer this here so that your final answer is 3x squared times cosine x cubed plus 1. So we are avoiding this because some students may think that it is possible to multiply this. Okay? It is not. Alright? Because this is the property of cosine. So you cannot touch this. No, you cannot combine this with 3x squared. Okay? Because it's owned by the cosine function. Okay? So let's have example number 1. Suppose we are given the function 5 over the quantity of x squared minus 3x plus 1. I think I'd like to change that now to x cubed. So the quantity of x cubed minus 3x plus 1 raised to the power of 4 or raised to the exponent of 4. So I hope you can remember what I gave you last time. 5 over x to the 4th. Right? So this time our x is quite complicated. Alright? So it's not a simple x. Okay? So if you can remember when we found when we were trying to find the derivative of the function 5 over x to the 4th, we had two methods, no? And then we learned that the second method is better than the other, although they come up with the same correct answer. Okay, so let's do that now. So this positive 4 here becomes negative 4 once it is written in the numerator. So that you have here 5 times x cubed minus 3x plus 1 raised to the power of negative 4. Okay, now let's start with the differentiation. Let's get the derivative now. So 5 is a constant, so place it outside so that negative 4 is here times, copy this, okay, copy. Do not get the derivative yet. So copy x cubed minus 3x plus 1. The negative 4 minus 1 becomes negative 5. Then that's the time, no? Using the chain rule again, that's the time you're going to get the derivative of x cubed minus 3x plus 1, which happens to be 3x squared minus 3. Okay, then let's try to multiply 5 times negative 4. That's negative 20. Then bring this down and bring this down. Then after which, since this is negative, then let's make that positive because according to what we learned in algebra, it is not yet the final answer if an exponent is negative or there is an exponent that is negative. So to make that positive, we write that down in the denominator so that you have the final answer. Negative 20 times 3x squared minus 3 all over the quantity of x cubed minus 3x plus 1 raised to the exponent of 5. Example number 2. Suppose we are given h of x equals the quantity of 2x minus 3 over 4x plus 5 raised to the exponent 3. So this time it's complicated. So let's use this formula, nu to the n minus 1. So that means we're going to write 3, then copy. Okay, take note again, copy first. Do not get the derivative yet. So copy 2x minus 3 all over 4x plus 5. Then 3 minus 1 here gives you 2. Okay, then after which, that's the time you get the derivative of the quotient here, u over v. So we have v du minus u dv all over v squared. Okay, the v is 4x plus 5. Derivative of 2x minus 3 is 2. Minus 2x minus 3, derivative of 4x plus 5 is 4 all over the square of 4x plus 5. Alright, let's simplify. The rest is algebra. So, because this is quite complicated, that means they are separated. Let's combine them into one fraction. So, bring down 3. Then you have to separate this, no? Separate this. So, they're both raised to the exponent of 2. So, you have 2x minus 3 squared times 4x times 2 is 8x. 5 times 2 is 10. 2x times 4 is 8x. Negative 3 times 4 is negative 12. Again, it's enclosed because of the negative sign. All over, this 4x plus 5 is also raised to the exponent of 2. And 4x plus 5 here is copied. 4x plus 5 raised to the exponent of 2. Then, let's simplify this. This is cancelled. And 10 plus 2, because that's negative of negative 12, plus 12. So, 10 plus 12 is 22. Now, 22 times 3 is 66. Copy this, 2x minus 3 raised to the power of 2 divided by the denominator, quantity of 4x plus 5 raised to the exponent 4. So, this becomes our final answer because there are no more chances of cancellation. Example number 3. Suppose you are given g of x equals cosine of 5x cubed plus 2x. So, it's not just an ordinary cosine x that we have learned in our previous discussions. So, again, there is more than that, more than x in the enclosed terms. Alright, so if that happens, then this is just similar to our illustration a while ago. So, the derivative of cosine is negative sign. Then, copy, alright. And then, that's the time you get the difference here. That's, of course, yeah. I'm sorry. So, we have here 5x cubed plus 2x. And the derivative of 5x cubed plus 2x is 15x squared plus 2. Again, it doesn't look good if they're adjacent to each other because some people or some students may multiply these binomials. Okay, so we have to place this beforehand. So we have negative of 15x squared plus 2 times sine of 5x cubed plus 2x, which is our final answer. Okay, so we have example number 4. Y equals tangent of secant of x cubed plus 1. This one is more complicated. So you have two functions. Okay, so don't worry. This will be easy as long as you follow the procedure very well. Okay, so it's not only 2 chains, you have 3 here. 1, 2, and then 3. Okay, let's do that. So first is you get the derivative of tangent. The derivative of tangent is secant squared. Then copy the whole thing here. Okay, so it's copied here. Then next is you get the derivative of your secant. The derivative of secant is secant tangent. So that means secant of, copy this also. So secant of x cubed plus 1 and tangent of x cubed plus 1. Then that's the time you get the derivative of x cubed plus 1, which is 3 x squared. So let's arrange this properly because it's not good to look at this, all right? So we write this here. So we have 3x squared second. Okay, now it's okay that this comes first, no? Then this. But of course, for me, I would like to write it this way. So you have 3x squared of second, x cubed plus 1, and tangent x cubed plus 1, and second squared of second x cubed plus 1. So that is your final answer. Example number 5, suppose you are given the function h of x equals the quantity of 2x cubed plus 5 raised to the power of 3 or to the exponent of 3 times the quantity of 5x minus 3 raised to the exponent of 2. So, you are going to apply your uv, that means u dv plus v du. But unfortunately, it's complicated because of the exponents, okay? Before, we have multiplied only binomials as simple as this, right? Now, notice that you have exponents other than 1, okay? So don't worry, it's still very easy. Okay, so all you have to do is copy the whole thing here, okay, which is now 2x cubed plus 5 raised to the power of 3 or to the exponent of 3. Then the derivative of this, which shall follow nu to the n minus 1. So you have 2, then 5x minus 3. Then the derivative of 5x minus 3 is 5. Don't forget that this is 1 because 2 minus 1 is 1. Plus, copy this one, 5x minus 3 raised to the exponent 2 multiplied by the derivative of this. So again, start with 3, then the enclosed terms, then 3 minus 1, that gives you 2. And then the derivative of 2x cubed plus 5 is 6x squared. Okay, so we're done. All we have to do, we're done differentiating. We're done getting the derivative. So all we have to do now is simplify using algebra. So 2 times 5, that's 10. Then bring down 2x cubed plus 5 raised to the power of 3 and 5x minus 3. Plus 3 times 6x squared is 18x squared. Bring down 5x minus 3 squared as well as 2x plus 3 plus 5 raised to the exponent 2. Then, all you have to do is look for common factors. Okay, so common to 10 and 18 is 2. That's why you have 2. And then, for the binomials, you look at the lowest exponent. So you can see that this one is lower compared to the 3. So that it becomes a common factor. And then this one has an exponent 1, which is lower to the exponent 2. So it becomes the common factor. So let's now find the leftovers here. So 10 divided by 2, that gives you 5. Then this one, we have 3 and this one is 2. So that means we still have the remaining one binomial. So you have 2x cubed plus 5 plus 18 divided by 2 or 18x squared divided by 2, that's 9x squared. And then, of course, this one, by the way, is cancelled here. And so that is not written here anymore. Okay, let's proceed. So 5x minus 3, we have 2. And this is 1, so that means there is still one pair of binomials. We have 5x minus 3. And since this is 2 and this is 2, then that's cancelled. Okay, so this is our leftovers. All right, so let's copy this, bring this down, and bring this down. Simplify this one. So 5 times 2x cubed is 10x cubed. 5 times 5 is 25. And then 9x squared times 5x is 45x cubed. And 9x squared times negative 3 is negative 27x cubed. Let's simplify further. So you have 10x cubed plus 45x cubed. That is 55x cubed. Then bring down negative 27x squared plus 25. So that is now our final answer. Okay? Because of course this one is now complicated to factor, and then of course we're not sure if it's factorable or not, but of course there is no possibility of combining them with the other binomials here. So that will be our final answer. Okay? Example number 6. What is the derivative of cotangent cube of 3x to the 5th plus 2x cubed? Okay, another complicated problem. Well, of course, as long as you have memorized the process, the procedure, the formula of the chain rule, this is going to be easy. So again, you start with a cotangent. Of course, not yet. There is an exponent, so you have to start with nu to the n minus 1. So you start with that. So that's 3. Then copy cotangent. Then 3 minus 1 is squared. Then copy. Alright, so still copy. It's much of copying here. Alright, then that's the time you get the derivative of your cotangent. So look at here. Para chain rule gid siya. Okay, so go back. Alright, you look back. Now, after copying this, you look back and see that the derivative of cotangent is negative cosecant squared. But of course, do not differentiate yet. You have to copy this. Okay? So, copy, that's the partner of cosecant, the partner of cotangent. So, you copy that. Then, next is you differentiate that. Okay? So, the derivative of that is 15x to the 4th plus 6x squared. Let's simplify or arrange. So, you have negative 3 because of the negative here. So, negative 3, then, yeah, move this here. So, you have 15x to the 4th plus 6x squared. Then, bring down cotangent squared, 3x to the 5th plus 2x cubed. And bring down cosecant squared of 3x to the 5th plus 2x cubed. Now, you can see here a common factor. So, the common factor is 3x squared multiplied by negative 3, that's negative 9. X squared, and then the leftover here is 5x squared plus 2. Okay, recall your algebra. That's 15x to the 4th minus 3x squared is 5x squared, 6x squared, divided by 6x squared divided by 3x squared is 2. Then bring down and bring down. So this becomes your final answer. Okay, so that's the end. That's the last example for today. I hope you have learned a lot and you have understood the discussion. Thank you very much. This is Dr. Batukan saying, mathematics is easy to learn when one learns with enthusiasm. Bye!